equidistant? Because of beta is constant. So beta is what? The distance between two consecutive dark or two consecutive bright fringes are same. Okay, so distance between two consecutive dark and the bright fringes are same, or you can say the constant. So therefore these are equidistant fringes. Okay, so this is a second important point. Okay, so if you have any query in this, you can raise. Yes. Any query? Please draw this diagram so that you will understand how the theta become constant. Okay. So the theta which has been generated, you can see the thickness is varying. The first thickness is at T1, then T2, then T3, etc. Okay. The thickness is changing, but your theta that remains constant for a particular dark fringe. Okay. So therefore the distance between these two dark fringes is same. So every time the distance between the two consecutive dark or maybe say bright, so that remain same. So therefore beta is constant. Got it? Any doubt? Okay. So should I rub this over? Now the third important point. Third important is fringes are localized. Fringes are localized. So why the fringes are called as localized fringes? So that also we have to see. So localized, as we know, the pattern, as I mentioned, so the pattern appears to be on the top surface of this glass slide. Okay. So there is a glass slide. These are the two glass slides. So this pattern that alternate bright, dark or bright, so that pattern appears on the top surface. Okay. And this pattern we can able to see with the naked eye. हम देख सकते हैं इस पैटर्न को, ठीक है, बट to take the observation, because the pattern is very close, okay, so we can see the pattern, but we cannot be able to take the observation with the help of naked eye. Okay, so while taking the observation, you can take the help of microscope. Okay, but you can see the pattern with the naked eye, so therefore it is called as fringes are localized. So इसका आंसर लिख लो. Fringes are localized means the fringes can be seen with the naked eye. The fringes can be seen with the naked eye. Okay? Why the fringes are localized? Because the fringes can be seen with the naked eye. Okay? Fine. So this is what about, you can say, the important points of the air gauge experiment that comes under the class of non-uniform thickness. Okay. So any doubt in the entire? Okay. So how much time we have? Huh? So can we have some numerical based upon this formula? Okay. So that is, you can go for. Yes. We can have numerical based upon this formula of beta. And please convey the message to those who have joined in online. So yesterday we have solved some numerical based upon the first topic. So I'm going to share that sheet in your Google Classroom, so that means it will not hamper to others also. Okay. Okay. So please note down fringes of equal thickness. Fringes of equal thickness are observed fringes of equal thickness are observed in a thin glass wedge. Fringes of equal thickness are observed in a thin glass wedge of refractive index, 1.52. Fringes of equal thickness are observed in a thin glass wedge of refractive index 1.52. First off, the fringe spacing is 1 mm. The fringe spacing is 1 mm, and the wavelength of light is 5893 angstrom unit. And the wavelength of light is 5893 angstrom unit. Full stop. Calculate the angle of wedge. Calculate the angle of wedge in seconds. Of an arc. Calculate the angle of wedge in seconds of an arc. Arc of an arc. Full stop. Okay. So once again, we'll read carefully. So what is given in the numerical? So fringes of equal thickness are observed in a thin glass wedge of refractive index 1.5. So what is given first? That is refractive index. So we can say mu, which is 1.52. Okay, and the fringe spacing is 1 mm. So fringe spacing, that is beta, which we denote by as a beta, which is 1 mm. So you can convert that 1 mm into meters. So how much? It will be 10 to the power minus 3 meters. Okay, so it will be 1 into 10 to the power minus 3 meters. Then, and the wavelength of light which is given, that is 5893 angstrom unit. So wavelength of light, that is lambda, which is 5893. So it can be written as 5893 into 10 to the power minus 10 meters. Okay. Then calculate the angle of wedge. So what is you have to find out is angle of wedge, that is theta. So angle of wedge means, in this diagram you can see, this diagram there is a theta. So this we have to find out. That is angle of wedge. Okay. So theta we have to find out, and that theta you have to get the answer in seconds. Okay. So that conversion that we will do later on. So first of all, these are the given terms. Okay. So mu, that is the refractive index of the medium, which is given 1.52. Beta, that is the fringe spacing, which is given 1 mm. Lambda, wavelength of light, and the wedge angle that we have to find out. So what is the formula here? So it is beta, which is lambda upon 2 mu beta. So this is a formula for beta, which is lambda upon 2 mu beta. Okay. So simply we have to substitute the values and we can get the answer. So therefore theta is equals to lambda upon 2 mu beta. So substitute the values lambda upon 2 mu beta. Okay. So after substituting, the theta that comes out to be 1.938 into 10 to the power minus 4 radian. Okay. So theta that will comes out to be 1.938 into 10 to the power minus 4 radian. Okay. Now you have been asked the angle of wedge in seconds. Okay. So you have to convert that radian into the second. So how can we to convert this radian into second? So for that, so you know this. So 1 radian, what is the conversion? Anyone know? What is the conversion? 1 radian, 180, yes. So it is 180 by pi, okay, in degrees. So 1 radian can be converted into degrees by 180 by pi. So as you know, 1 degree is equals to 60 minutes. So if you have to convert into second, it means 60 multiplied by 60 means 3600. Okay, so it means it will become 180 by pi into 3600 seconds. So this will be in second. Okay, so 1 radian, which is equals to 180 by pi into 3600 second. So you have to convert that. So it will be theta, which is equals to 1.938 into 10 to the power minus 4 into this term, into 180 by pi into 3600. Okay, we have converted this radian into seconds. Okay, so first what we did, we have converted the radian into the degrees. Okay, so degree is 180 by pi. Okay, and then we know the 1 degree equals to 60 minutes. So minute is been converted into second. So it will be 60 multiplied by 60. So it is 3600. Got it? Okay. So your final answer will comes out to be, so theta, which is 39.98. So theta, which comes out to be 39.98 second. The final answer for theta, that comes out to be 39.98 seconds. 39.98 seconds. Seconds. Okay. Yes. Any doubt in this numerical? Okay. One more we'll try. Yes. The second numerical, note down. A wedge-shaped air film, a wedge-shaped air film having a wedge-shaped air film having an angle of a wedge-shaped air film having an angle of 40 seconds. 40 seconds. Angle of 40 seconds is illuminated by monochromatic light, is illuminated by monochromatic light, is illuminated by monochromatic light, and fringes are, is illuminated by monochromatic light, and fringes are observed vertically, and the fringes are observed vertically through a microscope, full stop. The distance measure between consecutive bright fringes, distance measure between consecutive bright fringes is 0.12 centimeter. The distance measure between consecutive bright fringes is 0.12 centimeter. 0.12 centimeter. Full stop. Calculate the wavelength of light used. Calculate the wavelength of light used. Calculate the wavelength of light used. Full stop. Okay. Now see the given problem. Now there are the different terms we have. The problem can be asked in another ways, like you have to find out beta, you have to find out lambda, you have to find out order of the fringe, or you can be able to find out the refractive index. So all means whichever the terms are given and one term can be asked. So that kind of rotation of a particular numerical. So here it is asked like you have to find out the wavelength. Okay. So you know what kind of wavelength we can do to expect. So here also you can use a smartness. Smartness in the sense if your wavelength should be between 4000 to 7000 Armstrong unit. You should get the answer between this range only. Okay? If you are getting below this or above this, so your answer is totally wrong. Please ensure, okay? Because we are working on the visible range, visible spectrum. So your answer should be between this value only, okay? That should be in the visible range. So that you can get to cross verify. If you are getting more than 7000 or less than 4000, so your answer is totally wrong. So that is the one thing that you have to ensure. Got it? So now we'll see what are the given terms. So here the given is, you can see a wedge-shaped air film having an angle of 40 seconds. So angle which is given in 40 seconds. So now you have to convert in a reverse manner. So yes, reverse means पहले हमने क्या किया था 180 by pi. Now it will be pi by 180, so that you will get in radian. Okay. So convert this in a radian form first. So here 40 seconds, that is theta. So theta which is 40 seconds. So you convert this. So it is 40 into pi by 180 into 3600. Got it? Just a reverse so that you will get this answer in radian. Okay? So 40 into pi by 180 into 360, so that will be your radian. That is theta. Now the next one. Now this is illuminated by monochromatic light and